And let's talk about making thyroid hormone. You want to make thyroid hormone, what do you need?
Thyroid.
Thyroid, that's a good point. It's going to be difficult if you don't have one. This is iodine. Iodine ions, actually, they're negative ions. Those would be what, cations or anions?
Anion is anion.
Negative ones are anions. Okay, positive ones are cations. So you've got the iodine ions being collected. These are thyroid cells here, thyroid gland cells, and there's the lake. This time they didn't color it pink, they colored it yellow. Okay. So we get the iodine particles, ions, and we ship them over into the lake. Okay, what else goes in there? Well, the rough endoplasmic reticulum and the Golgi apparatus sends us some little vitamin capsules called tyrosines. And the tyrosines and the blue dots get together. So you can have one tyrosine and two blue dots, or you can have one and one. So this is mit and this is dit. Okay. What do you get when I put a mit with a dit? You don't get a trit, no. You get a T3. If you put two dits together, you get a T4. And those are the two flavors of thyroid hormone. So you're making thyroid hormone and putting it in a water balloon. What's that? No, a vesicle. A vesicle. And it's going to go over here, and you're going to be doing what? Secreting the hormones into the blood. Okay? So iodine was pretty important, wasn't it? It was basic to that. And tyrosine is actually, I believe, an amino acid. Okay? So you got all this going on here. It's interesting. Then I ask you, which one is more powerful, T4 or T3? T3 is more powerful. Okay? But they can be interconverted. Okay? So now we found out how the thyroid makes thyroid hormone in two flavors, T3 and T4. You say, that's pretty nice and simple, isn't it? Oh, don't doubt. Because, where is this now? There we go. This is page 3 of your note sheet. T4 is called thyroxine. Thyroxine. T3 is triiodothyronine. Okay. Both of them are thyroid hormones. When you get out to the target, though, T3 can be converted. It can be made from T4. And T4 is not as strong as T3. So you can make T3 out here, which is stronger, triiodothyronine. So they can be interconverted. So they're both being released. And most of the time, you're releasing thyroxine the most. And then it can be converted to T3, triiodothyronine. Any questions?
I have a question about the graphic.
Yes.
When it forms into the vesicle, it looks like it hits a lysosome. Is that just sucking out the...
That's a good question. I'm not exactly sure what the
Colloid fluid?
lysosome is doing, and I don't think they are actually explaining it here. So it says lysosomal enzymes cleave T4 and T3 from, okay, there's a thyroglobulin, kind of a transport molecule. So there is a transport molecule involved, thyroglobulin. Some things in the blood are on transport molecules. They aren't just free and easy, because you have to be a little careful with transport. So they're saying, okay, we're going to take off the thyroglobulin, and then before you send this out into the blood. Yes.
What did you call the water balloons? That
Vesicles. We did that before with vesicles. We did that with water balloons and little green dots. That's where you first heard vesicles. And look at that, the vesicle is actually made from the cell membrane here. And if you wanted to release these things, the cell membrane can go and become part of a cell membrane again, the vesicle can. It's a good system, there's no waste. You're not gonna have trash here, leftover vesicles, trash. It's gonna go back in and be reused as cell membrane again. All right. Well, you know, some people get upset by things they see. And this poor lady here, she's really being upset. She has bulging eyes because this lady who's smiling very nicely, she says, look at her. She's got a lump in her throat. See the lump in her throat? You know what that is? It's
Goiter.
goiter. The lady has a goiter. Okay, this one's upset. That's probably not true. But she's upset by the goiter, and the lady says, don't be upset. I've had this for a long time. You know what it is?
Iodine deficiency.
Okay, so what are we looking at?
An inflamed lymph.
A swollen thyroid.
Oh.
So her thyroid swelled up, and that's called goiter. Now, what would make a thyroid swell up?
Too much liquid?
Too much liquid, it's a thought. I don't think that's it though.
Oh, well, it says there iodine deficiency.
Yep, she is iodine deficient. But I want you to think about what would make a thyroid swell? What would make an endocrine gland swell? What if somebody were screaming at it? Could that do it?
Stress?
Stressful? Was screaming at you? Yeah, who would have the authority to scream at this thyroid gland?
Hypothalamus?
Hypothalamus. And even the what? The anterior pituitary. Why? Because the hypothalamus is screaming at the anterior pituitary. Says, why aren't you making thyroid hormone? Why aren't you doing it? And the anterior pituitary goes, hey, I told you thyroid, you're getting me in trouble. You're not making thyroid hormone. And the thyroid gland says, no, don't yell. Stop it, stop it. I'll try some more. I'm trying really, really hard and I just can't because
There's no iodine.
no iodine. I don't care how much you yell at it, the poor little thing can't do it because it needs iodine to make the hormone. So this lady says, yeah, but I haven't been eating iodine. And the thyroid goes, I know, that's the problem. So we live in a place where iodine should not be a problem. We live close to the beach, close to fishing. Seafood is high in iodine. So you really shouldn't be low in iodine if you're near the seaport, shrimp, and all that kind of stuff. But some people are allergic to it. That's true. Yes.
So is iodine the same as like when
When
doctors
you put on a cut or
clean?
something?
Yeah.
It is, but it's more concentrated. It's still iodine. I don't know if it's made into certain compounds, it might be. But that's the iodine we're talking about. You need some iodine. I wouldn't go drinking that stuff, not at all. But she needed iodine in her food and seafood has it. Some people, like I said, are allergic to iodine and they may be allergic to seafood because of that. So you have to back off of it, yes.
No, I am.
You are? So what do you have to do? Just not eat it?
Just not eat it.
And what about,
I just avoid it all.
I'm sorry?
I just avoid it all.
So what do you avoid in particular?
Anything that comes from the sea, besides canned fish or. Oh, salt? Not really.
You can eat the iodized salt?
Yeah.
Yes?
I just eat.
It doesn't bother. Okay. They decided, since this lady could live up in the mountains, she could have a wonderful garden with all kinds of potatoes and vegetables and tomatoes and corn, but she can't raise fish there. So she didn't get the iodine-rich foods, and so she got a goiter.
So if she were to eat iodine, then would it go
It's not gonna
back?
change it much now. Okay.
Would it would function? Sorry.
And they decided to put iodine in salt so that people could avoid this. That's why they made iodine salt. It's the what? No, it's not the same thing, okay?
But like, what is exactly making it bigger? Is it like just
The
too much
thyroid's
iodine?
getting bigger.
But is it like it's just expanding?
It's overworking. It's trying hard to do a job it can't do.
Okay.
It's being yelled at by the hypothalamus and the anterior pituitary, and it's trying and trying and trying, it makes it swell.
But it's not like hormones in there, it just can't make anything, so it's expanding
Yeah, it's
itself.
expanding under the stress,
Like
being told to do it.
runaway dysfunction or something.
It's a dysfunctional thing.
Okay.
Yeah. You're being told to do it, and it's swelling, but it can't do it. Interesting, isn't it?
Is that like hypothyroidism?
This is hyperthyroidism. Well, let me take that back. You'd be hyperthyroid if you're making a lot of the thyroid hormone. But in this case, it is kind of a hypothyroid situation. Yeah. You're trying, it's not because you aren't trying, you're trying, you just don't have what you need, iodine. And that's a problem.
And what is hyperthyroidism?
That's overactive thyroid. This one's overactive in the effect it's trying to do stuff, but it can't do it because it doesn't have the raw materials. So hyperthyroidism usually is, you got the right materials and you're making too much thyroid hormone. And that's what this lady's problem is. She's making too much thyroid hormone. She's hyperthyroid and her eyes are bulging. And that's called exophthalmos. And this is actually a hyperthyroid situation, specific one called Graves' disease. Yep, it's Graves' disease, and it's not uncommon. It's not uncommon. And the problem is, that is not from lack of iodine. That's from being, the thyroid's being attacked. Okay, the immune system is attacking the thyroid. That's not good. In the military, if you're shooting some of your members, that's not good. What's that called? Friendly fire, is it friendly? I don't think so. Shooting them is not, they're not gonna take that as a friendly action, okay? So your autoimmune diseases are where your immune system turns on the body and for some reason starts attacking it. And this one's attacking the thyroid, okay? And you'd say, well, the thyroid should be going, and shrinking down. But that doesn't happen. The thyroid gets hyperactive.
And so we'll get like swollen in those situations?
In this situation, it's not so much swollen, it'll probably go ahead and make more thyroid hormone. And that's what's making her eyes go ahead and bulge. It's also ramping up her metabolism and her heart rate and stuff like that. Hyperthyroid will do that. This type is autoimmune, so it's trying to destroy her thyroid, which makes you say, well then if it's trying to destroy it, it should be getting weaker, but it doesn't. And that's,
So it's fun. Yes, I'm fucking stronger.
well, actually, it's a weird situation that's interesting. The hyperthyroid here is because the thyroid thinks it's supposed to be making more thyroid hormone. Why would it think it's supposed to be making more? It's under attack. Antibodies are coming against it from the immune system. Why should it think that it's not under attack and it's just being told to make more? It's a point of confusion. You've confused the thyroid. What it thinks of the antibodies is that they're telling it to stimulate. It looks at the antibodies and they're so close to it, it thinks they're TSH. So it's a misunderstanding. The thyroid thinks it's being sent TSH, and thyroid stimulating hormones, so it stimulates. And it produces more thyroid hormone than it should, but it's at the same time the antibodies are attacking it. So it's not a good thing. But the response is, I'm being told to make more, so I'm making more. It's confused. And it's a misunderstanding that TSH and the antibodies sent at it look a lot alike. And it thinks those antibodies are telling it to work harder, work harder, work harder. So that's not good, because it's overdoing it, okay? And it's not good to be attacking your thyroid either. Anybody question? Yes.
Why are the antibodies attacking the thyroid?
Because in autoimmune diseases, your immune system starts attacking something in your body, which it shouldn't. But it gets confused and thinks it should. It thinks it's not part of its body, so it tries to destroy it. When you get a transplant, the immune system says, that's not me, and it tries to destroy it. You say, don't do that. I went through the operation, I'm taking drugs to limit the attacks. You say, don't do that. I don't want you to destroy my new kidney or my new heart. So you've got that problem. Your immune system wants to destroy anything it thinks is not right. And we call that rejection. They reject the transplant, yes.
Is it true that the immune system doesn't have, I'm sorry, that there's two immune systems, one for the eyes and one for the rest of the body?
That I didn't know. I don't know.
I've heard that the eyes are a very special area where the immune system doesn't have like jurisdiction.
Full control on that. I don't know. That I haven't heard. It may be, but I don't know.
How does it like get that signal to attack the body then? Is it randomly or?
It makes it up. I mean, it does. There's a part of thymus. We get back to thymus. There's a part of thymus that is supposed to try to help stop that. And the thymus is definitely weird. Thymus is really weird. Okay. You don't know this yet. What's the skin's, what kind of tissue do you have on skin? You have keratinized, stratified, squamous epithelium. That's skin. That's the top layer. Okay. The epidermis. It's keratinized, stratified, squamous epithelium. Keratin is kind of a tougher thing. So when they went to the thymus, they found whorls inside there that actually were keratin. So you had stuff that should have been on the skin inside the thymus. That was weird. And then some of the stuff they found out there was the thymus was trying to stop autoimmune with regulatory T cells. So it's weird. It does weird things. It's just weird, but that's okay. It's interesting. Okay, let's go on, because this is interesting too. What's the first thing you do when you look at a picture?
Get oriented.
Get oriented. Where are we looking?
Throat.
See this person? We're looking in the back of the neck, aren't we? So that is back into the throat. And there you see trachea. And notice, these are not complete rings, are they? So the rings in the trachea are reinforcing, but they're not complete circles. Why?
To swallow?
To give it movement, I'm using flexibility.
Yeah, a little bit. What's this? Esophagus, which should be running down through here. When you swallow a bolus of food, that's going, a bulge is it's going down through here, and the cartilages need to give a little bit of room for that, so that's why it is. It gives you space for swallowing a lump of food. Because this is right behind the trachea, esophagus is. Here are the two thyroid halves, and they got little marbles in them. See the little marbles, at least they colored them gold. Those are your parathyroid glands. They're embedded in the back of the thyroid. How many?
4.
2 here, 2 there, 4. But it isn't always that way. There could be 5. And one of the little marbles could be down in your chest. So if you had to take out the thyroid because of maybe a cancer tumor, you cannot get rid of these little parathyroid glands because you'd die if you didn't have them. So they can take those out and plug them into your chest and you'll be okay.
You said we could have 5?
Yeah, maybe even some more down in the chest. So they can grab them and stick them where you can let them live because your body needs that. So that's interesting. Okay, let's go on. Here we're looking at the adrenal gland. Okay. Remember, it has the adrenal medulla. What's that produce? That's the cat's out. What is it? Adrenaline, also known as what? Epinephrine. Epinephrine. Somebody who's badly allergic to peanuts or something like that, they'll walk around with a EpiPen. the epinephrine, okay? And that can open up your airways if they start closing, so you can breathe and don't die, okay? But this is the adrenal gland, and the medulla in the center is the one that makes the epinephrine and releases it. Norepinephrine is similar, not as much of it, but it also is produced there. Okay, and you remember norepinephrine from our smooth muscle with acetylcholine and norepinephrine, but it's not a part of this so much. Okay, so the medulla releases epinephrine, makes and releases it. But the outer part is called the cortex, the adrenal cortex. We have 3 zones: zona glomerulosa, zona fasciculata, zona reticularis. Zona glomerulosa, can we talk about this? I don't think so, then we really do need to. Let's go to the note sheet.